Impact of response latency and confidence on eyewitness accuracy. In 2002, Dunning and Peretta proposed the 10-second rule, which suggests that eyewitness identifications made faster than 10 seconds have a 90% probability of being accurate. Later on, Wells, Weber, and Brewer showed that this is only true when both confidence is high and the 10-second time boundary is used. In our study, we examined how decision time, confidence in choice, type of lineup, and face identification abilities can help to predict identification accuracy. 61 Nova State University students watched a video of a crime. They then rated how confident they felt about choosing the culprit from a lineup from 0 to 100%. Participants then completed the Cambridge Facial Memory Test, or CFMT. The CFMT involves learning to recognize 6 different faces from 3 different views and then testing recognition of the faces in a 3 alternative forced choice task. After the CFMT, participants were shown either a sequential or simultaneous lineup. We had 4 different lineups: target present and simultaneous lineup, target present and sequential lineup, target absent and simultaneous lineup, and target absent and sequential lineup condition. The target present lineups consisted of 7 distractors and the culprit. The target absent lineups consisted of 7 distractors and the victim. Participants were asked to identify the culprit and rate their confidence before and after identification. Reaction time in the simultaneous condition was recorded as the time between the lineup being displayed on the screen until the participant made a choice. In the sequential condition, for those that did not choose the correct target and for those in the target absent condition, reaction time was recorded as the total time spent on the line of photos. In the sequential condition, when participants selected the culprit from the lineup, decision time was recorded as time spent on the culprit photo before a decision was made. In order to create our decision time variable, the average time per photo was calculated as total time on lineup divided by 8 to match the measurement of decision time when the target culprit was chosen. Lineup accuracy was calculated 2 ways. 1. As lineup accuracy, correctly choosing the culprit or correctly rejecting a lineup without the culprit, and 2. As a signal detection response. First, we examined the correlation between decision time, facial identification ability, lineup accuracy, and post-lineup confidence, while controlling for type of lineup. The only significant correlation was between post-lineup confidence and facial identification ability. Those that scored higher on facial identification ability had significantly higher confidence in their choice after the lineup. Then, to address our main research question about whether lineup type, decision time, confidence in choice, and facial identification ability predict eyewitness accuracy, we conducted a linear regression with these variables predicting lineup accuracy. None of the variables significantly predicted accuracy, either as a measure by proportion of correct lineup decisions or when measured in terms of hits, misses, false alarms, or correct rejections. We did replicate the common outcome that sequential lineups produce a greater proportion of hits and correct rejections than simultaneous lineups. Lineup accuracy was significantly higher in the sequential lineup condition, 29%, compared to the simultaneous lineup condition, which was 16%. To explore further, we examined whether those that identified the culprit as measured by a hit were significantly faster in their decision time compared to those that missed, false alarmed, or correctly rejected the lineup. However, there was no significant main effect of type of signal decision response, indicating those that identified the culprit were not faster in their decision time compared to other participants. Furthermore, there was no significant difference between those that identified a culprit and the rest of the participants when it came to facial identification abilities. To this point, we have replicated the advantage sequential lineups have over simultaneous lineups in terms of cumulative hits and correct rejections, and have found that those with better facial recognition ability had higher confidence in their lineup decision. However, the variables of decision time, confidence, facial recognition abilities, and type of lineup do not predict decision accuracy. This is preliminary data, cut short by the pandemic, and we plan to continue data collection until we reach our target sample size. Thank you.